Okay, class, I'm going to give you another example, and I'm going to use three categories here. So basically what we're going to do with this scenario is we're going to find out ice cream preference for children, teenagers, and adults. Is there a significant difference between or within those three categories? And our null hypothesis, again, is going to be our observed scores are going to be equal to our expected scores, and our alternative hypothesis is going to be that there is a difference. They're not equal to the expected based on an alpha level of 0.05 and our degrees of freedom. So our degrees of freedom in this particular example, let me erase all this stuff here. So we'll just go with rows. How many rows do we have? Well, we got 2. I've got 2 rows minus 1 times, how many columns do I have? 3. 3 columns minus 1. So that's how we're going to determine our degrees of freedom. So 2 minus 1 is 1 times 3 minus 1 is 2. So 1 times 2 is 2. So I have, in this particular example, I have 2 degrees of freedom. So in my distribution, that kind of looks like the F distribution. It is positively skewed, as we remember. We're going to have a different critical value than we had in the last example. So if I look that up on my computer, 2 degrees of freedom and alpha level 0.05, I have a critical value of 5.99. And remember, think of that as standard deviations from the mean. And this is a chi-square distribution. So remember, our chi-square formula is going to be chi-square. I think I forgot this in the last example. It's going to be the sum of all of our observed values minus our expected values squared over the expected values. So I forgot to put this sum, but we did sum them because we added them all up. So now I have everything except my data. So children, I observed 14 children who preferred the chocolate, and I only had 6 who preferred the vanilla. Now the teenagers, I had 4 that preferred the vanilla and 18 who preferred the chocolate. Now the adults, I observed 26 who preferred the vanilla over 12 who preferred the chocolate. So this isn't saying that I'm not making a claim that as we age, our taste preferences change. What I'm saying is that there is a difference between the expected values of these 3 categories with preferences to vanilla and chocolate ice cream. So now, in order to get the expected values, what I have to do here is I have to add these columns up here. So 18 and 4 is going to be 22, and then 26 and 12 is going to be 38. So I'll have to erase my artwork here in order to do this. so I'll have to add this stuff up here. 6 and 4 is 10, should be 46. And then 14 and 18, should be, what, 33? Right? Well, let me get my calculator so I don't mess up. So, 14 plus 18 plus 12, 44. And now, I will grand total these. So 46 and 44. Hopefully I'll get the same thing here, 20 plus 22 plus 38. 80, I must have done something wrong. So, let me check my math again. 6 and 14, 20, 18, 22, 26, 12, 38, I did that right. So 6, 4, 27, I probably screwed up there. 26 plus 4 plus 6 is 36, that's where I screwed up. 36, so let's see if that'll make it right. So let me check these just to make sure. 14 plus 18 plus 12, 44, yeah. That's what happened, that's what I get for trying to do this in my head real fast. So, now it should equal 80. So 36 and 44, that's 80. Yep. And then 20 plus 22 plus 38, 80. Okay, now I'm good. Now, we could probably do the same thing as we did last time, but I'm going to show you another way how to do the expected values. And you can do that with the two categories, or you can do it the old way. You know, there's different ways of doing this. But these are pretty easy ways of doing this. So what I'll do is I'll take my column total, I will multiply it by my row total, and then I'll divide it by my grand total. So let's try that. So I've got 20 times 36, and that's equal to 720, and then I'm going to divide it by 80. That's going to give me 9. Good. So now I'll do the same thing, 20 times 44 divided by 80. So 20 times 44 equals 880 divided by 80, it's going to be 11. So there's my expected values for that. So I'll do the same thing for teenagers here. I'll take 22 and I'll multiply that by 36. 22 times 36 is equal to 792, and then I'll multiply that by 80. I'm sorry, divide that by 80. 22 times 36 is equal to 792 divided by 80. That gives me 9.9. So I'll round that up to 10 because dealing with people. Do the same thing for the chocolate category. I got 22 teenagers. I'm going to multiply that by the teenagers who like chocolate, which is 44, or all the people who like chocolate is 44. That gives me 968, and I'm going to divide that by 80, the grand total, and I get 12.1, or I'll round that to 12. And let's see, what do I do here? Adults. So I've got 38 adults, 38 times 36 who like vanilla, gives me a total of 1,368, and I'm going to divide that by 80, grand total. Give me 17.1, I will round that to 17. Do the same thing, I'll do 38 times the chocolate people, 44. And then I'll total that, 1672 divided by 80, and I get 20.9. I'll round that up to 21. So those are my expected values. Now, if I did it the old-fashioned way, like I did in the first example, I'll just take 36 divided by 80, gives me 0.45 or 45%. And I'll do the same thing here. 44 divided by 80 is going to be 0.55 or 55%. And I can take this row column here, or I mean the column, and I'll take 20. So you can do it either way. So I can take this row total of 20 and I can multiply it by 0.45, the percentage of this particular row here, and it gives me the same expected value of 9. So 20 times 0.45, which is 45%, is going to be 9. So you can do it either way, it doesn't matter. However you do it, it works out both ways. But those are our expected values. So we know that we have 2 degrees of freedom, and we know that we have a distribution that is not symmetrical, but it is positively skewed, and we're going to call this the chi-square distribution, and we have a critical value that holds 5%, the alpha level, in this region of rejection. And we said that we had a score of 5.99 as our critical value. And I'll double check just to make sure. .99 with 2 degrees of freedom. And how we got 2 degrees of freedom was our row total minus 1 times our column total minus 1. And when we calculated that, we got 2 degrees of freedom. So that's where we're getting all these numbers from. So now we can dive right in and actually do the math on this. So our test statistic here, the chi-square, is saying that we're going to sum all of our expected or observed values. We're going to subtract the expected values. We're going to square that. Then we're going to divide the expected values. So let's go ahead and do that. So I have 6 minus 9 squared over 9 plus 4 minus 10 squared over 10 plus 26 minus 17 over 17. I'm going to square that as well. And I'm going to jump down here to 14 minus 11. I'll square that over 11 plus 18 minus 12 over 12. Got to remember to square it. And then last but not least, the adult chocolate lovers, I've got 12 minus 21 divided by 21. And we're going to square those as well. We're going to square these to get rid of negative numbers. So let's start with 6 minus 9. That's going to be equal to negative 3. So 3 squared is 6, or 9, I'm sorry. So 9, and then 9 divided by 9 is 1. So we'll go over here to 4 minus 10 equal to negative 6. Negative 6 squared is 36, and we're going to divide 36 by 10, and we get 3.6 plus 26 minus 17 is equal to 9. So 9 squared is equal to 81 divided by 17 is going to be, wow, 4.764. plus, go down here to chocolate, 14 minus 11, it's 3. 3 squared, we said is 9. 9 divided by 11, equal to 0.8. 1/8. Okay, moving on to the teenage chocolate lovers. 18 minus 12 is equal to 6. We said that 6 squared was equal to 36, and we're going to divide that by 12, and we'll get 3. Now we'll move on to our adult chocolate lovers. 12 minus 21 equal to 9, negative 9. We're going to square that, and it's going to be 81. 9 squared is 81, divided by 21, 3.857. Now all we got to do is add all that up. So I got 1 plus 3.6 plus 4.764 plus 0.818 plus 3 plus 3.857 equals 17.0. So my obtained value for chi-square in this particular situation is 17.039. So my question to you is going to be, do we reject the notion that our observed values are equal to our expected values, or do we fail to reject that and accept the notion or the claim that we made, or maybe we didn't make a claim, that our observed values are not equal to our expected values based on an alpha level of 0.05 with 2 degrees of freedom. So that's what we're going to be doing. Your homework is actually going to be 2 rows and 2 columns, so obviously you're going to have 1 degree of freedom there. So I just gave you one of the steps, I think. So if you go back and, the degrees of freedom do not change based on, situation. They change based on rows and columns. So the 1 degree of freedom based on what I said last time, I can't remember what it was now, but it was 3 point something, I think. But that's it. That's your last homework. So let me know if I can help you with anything. I will load those review videos up for you, and I will talk to you in the next video. All right, have a good day.